Hello, this is G. Om Kedareshwara Kiran from Institute of Aeronautical Engineering at Department of Electrical and Electronics Engineering. Today the topic is about DC motor speed control using PID, Program Logic Control, or PID controllers. How a DC motor can be controlled using PID and Program Logic Control PLC. Now introduction to DC motor speed control is, in general, the DC motor speed control is direct current motor. The integral components in robotics, automations, and automotive systems where precise speed control directly influences performance and efficiency. Achieving accurate speed regulation poses challenges due to inherent non-linearities, external pole disturbance, and variations in motor parameter. Traditional control method often fall short in demanding application with require rapid response and stability. This presentation explores advanced control strategies, especially the PID controller, and address the complexities of optimal motor speed regulation. Understanding DC motors. DC motor model. A DC motor behavior couples electric element like armature resistance and inductor with mechanical dynamics. The transfer function mechanically relates applied voltage output speed, providing a foundation for control design. Typical specification: operating voltage 12 volts, rated speed 5000 rpm, torque 0.1 newton per meter. So these are the general specification. These define the motor capabilities and guide control system requirements and performance targets. Its key parameters include armature resistance, inductance, and back EMF constant, all influencing response characteristics. So these are about the DC motor model. Controlling of DC motor, the behavior, how the electrical elements and armature resistance, armature winding is behaved in the DC motor control, and a typical specification: operating voltage of 12 volts at rated speed of 5000 rpm, and torque is newton per meter, and it defines the motor capabilities and guide control, and the system enhance properties and the targets of different uh, performance targets and armature resistance, inductance, and winding. So these are the different types of the DC motor control, in where there is a voltage regulation and a PID controller using the speed control method. Now coming to the PID controller and overview. On the right side of the screen, we can see PIDI cloud protection, summarizing location, error, signal, integral, and PD and OD kit and plant. So the control mechanism is about the PID controller uses proportional, integral, and derivative terms acting on the error between desired and actual speed to generate the control signal. Mathematical expression: the control input u of t equals kp times over ki times an integral of the error and kd times of derivating the error, balancing, responsive, and stability. Impact terms: proportional controller of controls current error, integral eliminates steady state error, and the derivative antiseptics of future error trends and improve stability. The steady state error is nothing but it depends on the transient system and the steady state system. The transient system means the initial condition at 0 to rated value, and the rated value is a continuous constant, is called steady state. So these are the PID control overview. And now coming to PID controller tuning method. Ziegler-Nichols method, Konenkon method, consideration software auto tuning. Now first one, Ziegler-Nichols method, estimating ultimate gain and period over drive controller parameter and moderate overshoot stability in standard systems. The Ziegler-Nichols method estimating the gain of period of the drive controller and the parameter of the modern overshoot stability in standard systems. The next method is cone method utilizes open loop steady step response of parameter setting efficient for a process of significant delays. Software auto tuning. Modern tools like MATLAB and Python libraries automate tuning by analyzing system response in optimized performance and the matrices. Consideration balanced overshooting system, settling time and steady state error is a crucial when selecting tuning method of specific application needs. So these are the PID controller tuning methods, uh, considerations and software automatic tuning. Now coming implementation of PID controller and the for the DC motor speed system components speed sensor encoder and or tachometer providing feedback. The PWM generation adjust motor voltage for speed control microcontroller and Arduino of SMM32 running control algorithm. So these are about the system components of speed sensor generation microcontrollers. The closed loop architecture enables real-time correction for speed deviations, enhancing accuracy and response. Encoders measure actual speed, feeding data back into the controller, which adjusts the PWM duty to cycle algorithm. Microcontrollers execute PID computations for efficient making the approach suitable embedded applications. So these are the implementation PID controller for a DC motor speed, how the system components are working in the speed sensor PWM generation and microcontrollers and the microprocessors of PID controller with varying the motor speed. Now simulation and experimental result. Modeling MATLAB simulation rep- replicate motor dynamics and controller response, enabling pattern adjustments before hardware implementation. Performance matrices, then the hardware setup and compatibility analysis. Second one is hardware setup. Prototyping involves physical DC motor drives, encoders, and motor controllers to validate control performance. Performance matrices key indicators include rise time, settling time, overtime, shoot time, and the steady state error. Key indicators means include the rise time, settling time, overshoot, and steady state error, providing comprehensive insight into system behavior. And the fourth one is comparative analysis. Different tuning methods are compared experimentally to select optimal parameters for specific operational controllers, conditions and controllers. Advantages and limitations of PID controller is about the advantages, limitation, advanced techniques and real world experience. Examples. Advantages are simple structure and reboost in many applications, wide adaptation and support. Limitations limitations, tuning can be complex and over time consuming. Susceptibility noise efficient affecting the derivative terms and integrator wind up leading to performance degradation. Advanced techniques anti-wind schemes to prevent integrator issues, gain scheduling for varying operating points. The real world example is about industrial robotic arm and achieving plus or minus 0.1% speed accuracy using finite tuning PID controller, highlighting practical effectiveness. And conclusion and future directions. Summary is about PID controller remain the foundational method of effective and precise DC speed regulation, balancing simplicity with reliable performance, and it is adaptively make the suitable for broad range for application from robotics and automotive systems. Future trends: adaptive control to handle dynamic changes, fuzzy logic neural networks, and intelligent tuning sensor fusion enhancing feedback accuracy. Research continue innovating towards a robust and intelligent motor control strategies of extreme and complex environments. Thank you.